This our song, isn't it? Here we go. Yes. Hey, y'all. It is second grade math with Mr. Baird. It is second grade math with Mr. Baird. I am so glad that y'all are here with me because guess what? I am trying to make it as simple as possible for you so you can go on to the third grade. Because guess what? You cannot stay with me another year. You got to go on to the third grade. This is our second year together. You can't stay with me another year. You got to go on to third grade. I need you to be successful. So, of course, we're just going to do our video just the way we do in the classroom, guys. I want to make it as simple as possible for you. So, the first thing that we must do is do a review, okay? So, what are we going to review, Mr. Bear? Because, we've just been on break for a little bit. Wrong. You have not been on break. So, I hope you've been working on your packet. All right, so we're going to review arrays. And of course, we know that arrays are an arrangement of objects into rows and columns. But by the end of it, like I said, Mr. Baird is trying to make you successful. So by the end of it, I want you to ask yourself this question. How does arrays and repeated addition relate to multiplication? See, in second grade, we were learning how to repeat addition, okay? But in third grade, you are going to be learning how to multiply. So how does that relate to multiplication? How does arrays relate to multiplication, Mr. Beard? All right, so let's go to it. So I'm going to pull up our document camera, and this is actually the first page of your learning packet. So if you can pull it out, it's the first page of your learning packet. All right, let's look at it. It says, let me make sure it adjusts itself. All right. It says Jaleesa has 12 stuffed animals. She wants to put the same number of animals in each of her 3 baskets. Draw a picture to show how she can put the animals into 3 equal groups. So how can Jaleesa put those animals into 3 equal groups? So it says draw a picture. So let's go back to the information part of our word problem. It says Jaleesa has 12 stuffed animals. So how many does she have? 12. But she wants to put the same number of animals in each of her 3 baskets. Each of her 3 baskets. So I'm going to give you some time and I want you to think about how can Jaleesa put those 12 stuffed animals into her 3 baskets? All right, so it says draw a picture to show how you can put the animals into 3 equal groups. So I'm going to do 1 basket right here. I'm going to do my second basket right here. And I'm going to do my third basket right here. Okay? So she has 12 of them. So I need to now place 12 stuffed animals into each of these baskets. So I'm going to say 1, that's my stuffed animal. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I got to 12. I got to 12. Now what? Okay. So how can she put the animals into 3 equal groups? So how many did she put into the basket? Each of the basket have how many? 4. That is absolutely correct. I knew that you would get it. Each of the baskets have 4 stuffed animals in them. Now, the question that Mr. Ved posed was, how can you relate repeated addition to multiplication? All right, well, let's look at it. How can I create a repeated addition equation to multiplication? All right, so if I were to go with my pictorial representation, I would say that I have 4 right here plus another 4 right here, plus another 4 right there. And it's going to give me the total of 12. But how can I relate that to multiplication? Well, I added 4 3 times. I added 4 3 times. So a simple multiplication equation that I could create was 4 times 3 equals what? 12! 4 times 3 equals 12. All right, 4 times 3 equals 12. So guess what? That's one less multiplication fact that you have to know. All right, so guess what? How did we relate our arrays to repeated addition and equation and to multiplication? Now I'm going to move on to your word problem. All right, it is on that same sheet. Just flip it over. It is on that same sheet. Just flip it over. All right. So first, you must underline your question and then use your strategy. Underline your question and then use your strategy. So let's look at it. And of course, there's still some. You can see what I wrote on the back, but it's okay. All right. It says a fruit seller buys a carton of 9 apples, finding that 18 of them are rotten. He throws them away. He sells 22 of the ones that are left on Monday. How many apples does he have left to sell? Now, how many apples does he have left to sell? It says draw a picture and write and solve an equation. All right, so the first thing I must do is underline my question. How many apples does he have left to sell? After I underline my question, what is the first thing that I must do? I'm hearing a lot of different things. What are the first thing that I must do? Go back to the information part of my word problem. A fruit seller buys a carton of 90 apples. So we already know that we have 90 apples. Cool. It says finding that 18 of them are rotten, he throws them away. So he has 90 apples and 18 of them are rotten, so he throws them away. So if I am going to throw something away, am I going to add to my 90 or am I going to take from my 90? Am I going to add to my 90 or take from my 90? I am going to take from my 90. So 90 subtract 18 equals what? So, of course, I can use my base 10 strategy. I know that these 2-digit numbers have tens and ones in them, so I can draw my place value chart with my tens and ones. And I know that 90 is 9 tens. It has 9 tens in that number. Does everyone see those 9 tens? So I'm going to write 1, 2, 3, 4, 5, 6, 7, 8, 9 tens. And 90 has 0 ones. But I need to take away 18. So it says that I must take away 110. So let me take away 110. And now I need to take away 8 ones. I need to take away 8 ones. So because I do not have any ones to take away, I must decompose or unbundle a 10 and add it over here to my ones. Now I have 8 ones that I can take away. 1, 2, 3, 4, 5, 6, 7, 8. So how much do I have left? How much do I have left? So I can look at it and I can see that I have 2 ones left and I have 1, 2, 3, 4, 5, 6, 7 tens left, and I have 72. But I am not finished because he threw those 18 away. And then it says he sells 22 of the ones that are left. So if he has 72 left, oh, I made a mark. If he has 72 left and he sells 22 of them, that means I am getting rid of them. Then 72 minus 22 equals what? And I can use that same strategy. Tens and ones. I have my 7 tens and 72 and my 2 ones and 72. I must get rid of 2 tens. So I eliminated my 2 tens. And I can get rid of my 2 ones. So I have 0 ones left and 5 tens. So now, how many apples does he have left to sell? He has 50 apples left to sell. And because I want you guys to be successful scholars, I'm going to write it in a complete sentence. I'm going to say, he has 50 apples left to sell. He has 50 apples left to sell. So, guys, I do not want you to get bogged down into thinking that you do not know how to solve the word problems using your different strategies. You know how to solve these word problems. I have complete faith in you. Okay? I have complete faith in you. So, we're done with our review. We are done with our review. So now, guess what? We are going to do something new. Something new. And let's get to it. Something new. All right. So let's see. We're still doing our second grade math with Mr. Baird. And I'm going to go into this part of my PowerPoint. So I'm going to start with shapes and their attributes. Here we go. Oh, yes. You know we got to turn up. Hey, shake it out, West. Baby, come give me something. Oh. Baby, come give me something. Oh. All right, so we are doing something new. Something new. So I have 2D shapes and their attributes. 2D shapes and their attributes. By the end of this lesson, you will be able to reason with shapes and their attributes. So your I can statement is, I can reason with shapes and their attributes. But what does it mean to reason? I can reason with shapes and their attributes. Well, another word for reason is to explain. So I can explain what shapes are and their attributes. But what are attributes? Just descriptive words. So, of course, we know we have been doing shapes since kindergarten. and first grade. I remember specifically teaching that, and it is going to be so interesting. It is nothing but a review. All right, so 2D shapes are flat. 2D shapes have corners or vertices and sides. So sides are the shape, sides are the sides of the shape. And as you can see, this square right here, it labels the sides. But the corner or the vertice or vertex is where the 2 points meet. All right, so let's look at it. Now, the reason why I have the word vertices in parentheses is because corners are kindergarten and first grade words. We're now in second grade preparing for third grade, so we're going to say vertices. Repeat after me, vertices. Say it again, vertices. Okay, let me just come back bigger for you. Y'all, do not say corners, say vertices. Vertices. When we are describing shapes or listing their attributes, we say vertices. Now let me come through this screen and hear you say corners. Don't let me come through this screen. Don't let me come through this screen. All right, we say vertices. All right, so here we go. So let's look at our first shape, which is a rectangle. This rectangle, it has 4 straight sides. So I'm going to look at each side. 1, 2, follow my mouse, 3, 4. It has 4 straight sides. Bam. It shows you how many sides it has. 1, 2, 3, 4. All right. And it has 4 vertices, or the corners, but we say vertices. Here we go. 4 vertices. 1, 2, 3, 4. And the vertices are where 2 lines meet. Now, here are some real life examples of things that are shaped like rectangles. You have this door, this envelope, this pan, and these cards. All right, our next shape is a triangle. A triangle has 3 straight sides. Does everyone see those 3 straight sides? 1, 2, 3. And it has 3 vertices where 2 lines meet. 3 vertices right there. 1, 2, 3. A circle. A circle is kind of tricky. It only has 1 curved side, but it does not have any vertices because there is no way that 2 lines are going to meet at a point. So it just goes on and on. Here are some real life examples. This button, this coin, the face of this watch, and this Ferris wheel. Let's look at a square. This square has 4 equal straight sides, which means that the equal sides are the same length. So if I were to say that the square has a side length of 2 inches, all of the sides must be 2 inches because they are 4 equal sides. 1, 2, 3, 4, 4 sides. And it has 4 vertices. 1, 2, 3, 4, where 2 lines meet. So we're able to reason and say that this square has 4 straight sides and vertices with their attributes. We have an oval. An oval is similar to a circle. However, it is elongated just a little bit. So, of course, it has 1 curved side and 0 vertices. You can look at the frame of this mirror, this ball right here, this football, and this egg. And we have a hexagon. The hexagon has 6 straight sides. 6 straight sides. 1, 2, 3, 4, 5, 6. 6 straight sides. And it has 6 vertices. 1, 2, 3, 4, 5, 6. What did I say a vertice was? Where 2 lines meet. A vertices is where 2 lines meet. All right, so let me see if you can reason. Y'all know I love to say, let me see. All right, and of course, when I say let me see, I want you to show me what you know. I want you to show me the name of each shape and how many sides and vertices and the real life example. Let me see. So, what is the name of this shape? Let's reason and explain the name of this shape. I'm going to give you some time. What is the name of this shape? If you said rectangle, you are correct. How many sides does this rectangle have? How many sides does this rectangle have? Come over here. How many sides does this rectangle have? 4 sides and 4 vertices. Now, which one of these pictures is our rectangle? It's shaped like a rectangle. If you said the envelope, you are correct. All right, let's move on to another one. What is the name of this shape? What is the name of this shape? If you said triangle, you are right. So how many sides and vertices? How many sides and vertices? 3 sides, 3 vertices. Which one of the following real life objects has a triangle in them? You're so amazing. That flag. All right. What is the name of this shape? It is a circle. How many sides? Oh, and it says curved. How many curved sides does it have? And how many vertices? It has 1 curved side and 0 vertices. All right. So which one of the pictures is shaped like a circle? The coin. The coin is shaped just like a circle. All right. So what is the name of this shape? It is a square. Now, how many sides have equal length? How many sides have equal length? How many sides have equal length? And how many vertices does it have? 4 equal sides with equal length and 4 vertices. And the clock is shaped just like the square. Let's look at this shape. It is an oval, correct? How many curved sides and how many vertices does this shape have? All right, it has 1 curved side and 0 vertices. Now, which one of the objects is shaped like an oval? You are absolutely correct. The egg. Let's look at the hexagon. I gave it to you. I gave it to you. Let's look at the hexagon. How many sides does this hexagon have? You can count. How many vertices does it have? Exactly. It has 6 sides and 6 vertices. All right. And this ring is shaped just like a hexagon. All right. So I'm going to come back to my document camera and I'm going to give you just a little bit. Let's look at this red triangle. See, I'm describing the attributes. The red triangle. The red triangle has 3 sides and 3 vertices. So let's write it in a complete sentence. The red triangle has 3 sides and 3 vertices. The red triangle has 3 sides and 3 vertices, and we were just able to reason about shapes and their attributes. Let's do another object. Here we go. How could we formulate that into a complete sentence? If you said the green rectangle has 4 sides and 4 vertices, you are correct. So the green triangle has 4 sides and 4 vertices. Let's do one more, just so I can know that you got it. That you are able to reason with shapes and their attributes. That shape is a what? It is a circle. And how am I going to formulate my sentence? You are correct. The clear circle has 1 curved side and 0 vertices. I know I said this was the last one, but let me do one more, guys. One more. Here we go. The red square. The red square has 4 equal, and we know that equal means the same, equal sides and 4 vertices. 4 equal sides and 4 vertices. Period. All right. So, guys, I want to go back to the first part. By the end of this lesson, you have now learned to reason with shapes and their attributes. Now, you reason by just explaining what shapes are and their attributes. Now, I want to go over the first part of your learning packet, which is right here. Simply identify the number of sides and angles, which is vertices. They just have a different word. Side and angles for each shape. Circle each angle as you count. Circle the vertices as you count. So I'll do the first one with you. All right, so let's look at this problem A. All right, so how many sides? Let's count. 1, 2, 3. So I can say 3 sides. How many angles or vertices? We have 1, 2, 3. You think you got it? You think you can do it on your own? I can trust that you can do it on your own. Guys, well, that concludes my lesson. I want you guys to comment down on this video below. I want you guys to tell me any questions that you have, okay? And if you just want to say, Mr. Baird, I need some help, guess what? You can write that too. All right, so until next time, guys, I know that you guys are going to be successful. I know that you guys are going to reason with shapes and their attributes and have this done flawlessly. Until next time, guys. Uh-oh. I'm trying to get off. And I'm trying to exit with the music, and they won't even let me exit with music. So let's start it over. And let's do it again. There we go. Jam with me. Yeah, I wanna take my horse to the old town road. I'm gonna ride till I can't no more. I'm gonna take my horse to the old town road. I'm gonna ride till I can't no more. I got the horses in the back. Horse stock is attached. And it's mad black. I love you guys.